Hey guys, so in this video I'm going to go over how to predict your products for double replacement, how to write your complete and your net ionic reactions as well. Okay, so for this one we're going to do barium chloride. Now barium has a +2, chlorine has a -1, so when you write the formula you have to make sure you have 2 chlorines. Plus we're going to do Na2SO4, which is sodium sulfate. I'm going to walk you through how to predict this. Change colors. Okay, so in this, the first one that's here combines with the second thing that's over here. So notice that I'm circling the 4 because it is part of SO4, which is sulfate. Those two are going to go together. Every time you write a compound, you need to use your charges. Well, Ba has a +2, SO4 has a -2. If you don't have your polyatomics listed or memorized, hey, you know what? You're stuck at home right now, so you have access to that. Make use of your resources. Your next compound, I'm going to change to blue here, will be the insides. Now that 2 was not part of the polyatomic, and neither is that one, so don't circle it. Don't put those together. Those do not carry over. In fact, when you're predicting it, Na is a +1, Cl is a -1. So it's good as just NaCl. Okay, now that you've predicted your products, you should always balance. So to balance it, I just need a 2 right here. Now we're going to look at our solubility chart. Now, I just don't have the function right now to have this chart in front of you. It is, however, linked in the targets where you got this video. At the top of that assignment, it's linked in the targets. It's also linked at one of the top modules in the Canvas course. So you look at the solubility rules, and when you look at Na, we're going to start with NaCl. Well, Na is an alkali metal, and Cl is a halide. Okay, halides are normally soluble, which is AQ, unless it's with Ag, Hg, or Pb, which it's not, so this will stay AQ, and that's what you write. For BaSO4, sulfate is on the list, and it is normally AQ unless it's with CaSrBa, which it's right there, and a few other things. So that makes this a solid. All right, now for your complete ionic. To do that, we actually have to know the solubility of our reactants as well. So if you look at it, Cl, again, is a halide and is normally AQ. It's not with an exception, so it stays AQ. Na is an alkali metal, and it is always AQ. So I have 3 things that are AQ and 1 thing that is a solid. When you are writing your complete ionic, you want to include all of the ions that are present with the charges, with the symbols AQ or S. So when you're doing this, BaCl2, when it's together, is AQ. What that means is it dissolves in water, and when it does that, it completely splits up. So your Ba is separated from your Cl. Well, Ba always has a +2 charge, so you got to make sure you include it, and it has an AQ. Now there are 2 Cl's, each one is a -1, and they are AQ. Na2SO4, well, that's AQ as well, so the Na, there's 2 of them. Each Na is a +1, and it's AQ, so you're going to leave that AQ. Plus 1 SO4. Now, the 4 stays there because it's part of the polyatomic. That whole thing has a -2 charge, and it is also AQ. Now I'm out of room, so I'm going to draw my arrow, and I'm going to continue down here. BaSO4, that's an S. What an S means is it does not break apart. So we don't want to show it breaking apart. We want to show it together. So you're just going to write it exactly as you see it. And then we have 2 NaCl's. So I have 2 Na, that's a +1, that is AQ. And I have 2 Cl's, each one a -1, and it's AQ. All of that breaks apart. Now, when you're writing your net ionic, you look from left to right to see what does not change. That's how I do it. I look to see what does not change. Well, Ba is going from an AQ to it's now combined in an S. That is changing, so I want to leave it alone. I have 2 Cl's that are negative, and they're staying as 2 Cl's that are negative in AQ. So I'm just going to kind of do a little cross through on those because they aren't changing. So when I write the net ionic, I don't want them. 2 Na's, both AQ, both with a +1. That's not changing. Let's cross that off. SO4 negative 2AQ is changing into SO4S. So these are the things that are changing, and I want to write my complete ionic only with them. So to do that, I just literally copy it down. So notice that I have AQs on everything, or I have S's. On the complete ionic, I have my charges anywhere that it's an AQ. If it's an S, then I just write it like normal. Okay, so this is how you do a double replacement. You predict your products using the inside-outside method. Make sure that you don't include those 2's that I was kind of talking to you about. Don't include these little numbers right here unless they're part of the polyatomic. From that, you determine your solubility using the solubility charts on the back of that periodic table, which is linked on Canvas for you. If it's AQ, you split them apart like we did BaCl here, because it was AQ, and like we did Na2SO4, and like we did NaCl. Okay, the only one that we didn't split was the S. When you write the net ionic, basically you determine what's the S, that's not going to change, determine what it is that took to make that S, and write it down. If both products were AQ, then that's a no reaction. And once you complete that first step of predicting your products, balancing, and writing AQ and S, you're done. Okay, that's it for today. Now, after this video, you have 3 problems that you need to solve, and you're going to take a picture of it and submit it on Canvas. The button to submit is at the top. You should see a blue submit button. That's what you want to click, and there should be a button like media or picture or gallery, whatever it takes. Take a picture of it and submit it. Please make sure that we can read it, otherwise we can't give you the feedback that you need in order to move forward with this. Okay, I know this is new for all of us, working from home and all that good stuff, so be sure to email your teacher if you have any questions at all. We are there. Our office hours are 9 to 11 a.m. and 1 to 3 p.m., so be sure to email. If you email outside those hours, we'll get back to you the next office hours that we have available, but do go ahead and email.